Dear friends, myself Harshavardhana CN, Assistant Professor of Mathematics. In this session, we are going to discuss Jacobian, examples for Jacobian and problems on Jacobians. If u and v are functions of two independent variables x and y, then the determinant del u by del x, del u by del y, del v by del x, del v by del y is called the Jacobian of u and v with respect to x and y, and is written as del of uv divided by del of xy, or Jacobian of uv with respect to x and y. Similarly, the Jacobian of three variables uv,w with respect to xyz is del of uv,w divided by del of xyz equals to the determinant del u by del x, del u by del y, del u by del z, del v by del x, del v by del y, del v by del z, del w by del x, del w by del y, del w by del z. Del u by del x is partial differentiation of u with respect to x. Del u by del y is partial differentiation of u with respect to y. Del u by del z is partial differentiation of u with respect to z. Similarly, del v by del x, del v by del y, del v by del z are partial differentiation of v with respect to x, y, z respectively. Similarly, del w by del x, del w by del y, del w by del z are partial derivative of w with respect to x, y, z respectively. The Jacobian of n functions of n independent variables can be defined in similar way as defined above. Now we are going to prove a theorem. If Jacobian j equals to del of uv by del of xy and the inverse Jacobian j dash equals to del of xy divided by del of uv, then j into j dash equals to 1. Next we are going to prove this. Let u equals to f of xy and v equals to g of xy. That is, u and v are functions of x and y. Suppose on solving for x and y, we get x equals to pi of uv and y equals to psi of uv. That is, we get x and y are functions of u and v. As I defined partial derivatives in our earlier sessions, del u by del u equals to 1, which is equals to del u by del x into del x by del u plus del u by del y into del y by del u. Also, del u by del v equals to 0, which is equals to del u by del x into del x by del v plus del u by del y into del y by del v. Also, del v by del u equals to 0, which is equals to del v by del x into del x by del u plus del v by del y into del y by del u. Also, del v by del v equals to 1, which is equals to del v by del x into del x by del v plus del v by del y into del y by del v. Now, j into the inverse Jacobian j dash equals to del of uv by del of xy into del of xy divided by del of uv equals to, now del of uv divided by del of xy is determinant of del u by del x, del u by del y, del v by del x, del v by del y into del of xy by del of uv is determinant of del x by del u, del x by del v, del y by del u, del y by del v, which is equals to determinant of del u by del x into del x by del u plus del u by del y into del y by del u, del u by del x into del x by del v plus del u by del y into del y by del v, del u by del x into del x by del u plus del v by del y into del y by del u, del v by del x into del x by del v plus del v by del y into del y by del v. From our previous slide, this value equals to 1 and this value equals to 0, this value equals to 0 and this value equals to 1. Therefore, j into j dash equals to determinant of 1 0 0 1, which is the determinant of 2 cross 2 identity matrix, which is equals to 1. Therefore, j into j dash equals to 1, where j is the Jacobian and j dash is the inverse Jacobian. Next, we are going to find Jacobian and solve some problems on Jacobians. The first problem is, if u equals to 3x plus 4y, v equals to 4x minus 3y, then find j equals to del of uv by del of xy. Solution. We know that by the definition of Jacobian for functions of two variables, j equals to del of uv by del of xy, which is equals to determinant del u by del x, del u by del y, del v by del x, del v by del y. Now, u is 3x plus 4y, therefore del u by del x is 3, del u by del y equals to 4. Also, v equal to 4x minus 3y, del v by del x is 4 and del v by del y is minus 3. Substitute in the above formula, j equals to determinant of 3, 4, 4 minus 3. Expand this determinant, j equals to 3 into minus 3 minus 9 minus 16. Therefore, j equals to minus 25. Therefore, the Jacobian is minus 25. Next, the second problem is, if u equals to x square and v equals to y square, then find del of uv by del of xy and del of xy by del of uv. Also verify that the product of these two is equals to 1. So we have the Jacobian transformation of uv with respect to xy is equals to j equals to del of uv by del of xy equals to determinant of del u by del x, del u by del y, del v by del x, del v by del y. Now we del u by del x equals to 2x, del u by del y equals to 0, del v by del x equals to 0 and del v by del y equals to 2y. Substitute here. Therefore, j equals to determinant of del 2x, 0, 0, 2y, which is equals to 2 into 2, 4xy minus 0, which is equals to 4xy. Therefore, the Jacobian is equals to 4xy. Now, the given u equals to x square and v equals to y square, which implies x equals to root u and y equals to root v. Also, we know that inverse Jacobian j dash equals to del of xy divided by del of uv, which is equals to determinant of del x by del u, del x by del v, del y by del u, del y by del v. Now, since x equals to root u and y equals to root v, del x by del u equals to 1 by 2 root u, del x by del v equals to 0 and del y by del u equals to 0 and del y by del v equals to 1 by 2 root v. Therefore, substitute here, j dash equals to determinant of 1 by 2 root u, 0, 0, 1 by 2 root v. Therefore, j dash equals to the determinant 1 by 2 root u into 1 by 2 root v equals to 1 by 4 root of uv, which is equals to 1 by 4 root of our u is x square and v equals to y square. Substitute here, which is equals to 1 by 4xy. Now consider j into j dash equals to j is 4xy and j dash is 1 by 4xy. These two gets cancelled. The product equals to 1. Therefore, we verified j into j dash equals to 1. That is, the product of Jacobian and its inverse Jacobian is equals to 1. Next, the third problem is, if x equals to r cos theta, y equals to r sin theta, then find j equals to del of xy divided by del of r theta and j dash equals to del of r theta divided by del of xy. Also verify j into j dash equals to 1. Solution. Given x equals to r cos theta and y equals to r sin theta. See here, if x equals to r cos theta, y equals to r sin theta. Now consider x square plus y square equals to r square cos square theta plus r square sin square theta, which is equals to r square into cos square theta plus sin square theta. Therefore, x square plus y square equals to r square into 1, which is equals to r square, because cos square theta plus sin square theta equals to 1, which implies r equals to square root of x square plus y square. Also consider x by y equals to r cos theta divided by r sin theta. Therefore, theta equals to tan inverse of y by x. Now we have J equals to del of xy divided by del of r theta equals to determinant of del x by del r, del x by del theta, del y by del r, del y by del theta, which is equals to, since x equals to r cos theta, y equals to r sin theta, which is equals to determinant of del x by del r is cos theta, del x by del theta is minus r sin theta, del y by del r equals to sin theta, del y by del theta equals to r cos theta. Expand this determinant, which is equals to r into cos square theta plus r into sin square theta. Take r as common, r into cos square theta plus sin square theta, which is equals to r. Therefore, Jacobian J equals to r. We have inverse Jacobian J dash equals to del of r theta divided by del of xy equals to determinant of del r by del x, del r by del y, del theta by del x, del theta by del y. Now r equals to square root of x square plus y square and theta equals to tan inverse y by x. Therefore, del r by del x equals to 1 divided by 2 root of x square plus y square into 2x, which is equals to x divided by r, because 2 gets cancelled. Root of x square plus y square equals to r. Also, del r by del y equals to 1 divided by 2 into square root of x square plus y square into 2y, which is equals to 2 gets cancelled. Y divided by square root of x square plus y square is r. Also, here theta equals to tan inverse y by x. Del theta by del x equals to 1 divided by 1 plus y by x whole square into minus y by x square. By simplifying, we get which is equals to minus y divided by x square plus y square, which is equals to minus y divided by r square. Also, del theta by del y equals to 1 divided by 1 plus y by x whole square into 1 by x, which is equals to x divided by x square plus y square, which is equals to x by r square. Now, substitute in the above, the inverse Jacobian J dash equals to x by r, y by r, minus y by r square, x by r square. Expand the determinant, x by r into x by r square equals to x square by r cube, minus into minus plus y by r square into y by r is y square by r cube, which is equals to take r cube as LCM, x square plus y square divided by r cube, which is equals to x square plus y square is r square by r cube, which is equals to 1 by r. Now consider j into j dash equals to r into 1 by r, which is equals to 1. Therefore, we verified j into j dash equals to 1. Therefore, Jacobian transformation into inverse Jacobian transformation equals to 1. Next, the fourth problem is if x equals to u into 1 minus v, y equals to uv, then find j equals to del of xy divided by del of uv and j dash equals to del of uv divided by del of xy. Also verify j into j dash equals to 1. Solution. Here given x equals to u into 1 minus v, which implies del x by del u equals to 1 minus v and del x by del v equals to minus u. Also given y equals to u into v, which implies del y by del u equals to v and del y by del v equals to u. Now the Jacobian transformation equals to determinant of del x by del u, del x by del v, del y by del u, del y by del v, which is equals to substitute using above determinant of 1 minus v minus u v u. Expand this determinant, which is equals to 1 minus v into u is u minus uv minus into minus plus uv, which is equals to minus uv plus uv gets cancelled, which is equals to u. Also, we have x equals to u into 1 minus v, which is equals to u minus uv, and y equals to uv, which implies v equals to y by u. Now consider x plus y equals to u minus uv plus uv, which implies u equals to x plus y, and v equals to y divided by u means y divided by x plus y, which implies del u by del x equals to 1, del u by del y equals to 1, and del v by del x equals to minus y divided by x plus y whole square, and del v by del y equals to use quotient rule, denominator square, denominator differentiate numerator minus numerator differentiate denominator. Therefore, del v by del y equals to 1 by x plus y whole square into x plus y into 1 minus y into 1. Simplify this. Del v by del y equals to x divided by x plus y whole square. We have inverse Jacobian j dash equals to del of uv divided by del of xy, which is equals to determinant of del u by del x, del u by del y, del v by del x, del v by del y, which is equals to, substitute using above, 1 minus y divided by x plus y whole square, x divided by x plus y whole square. Therefore, j dash equals to, expand the determinant, 1 into x divided by x plus y whole square is x divided by x plus y whole square plus minus into minus plus y divided by x plus y whole square into 1, which is y divided by x plus y whole square, which is equals to, take x plus y whole square as LCM, we get x plus y divided by x plus y whole square, which is equals to 1 x plus y gets cancelled with x plus y whole square, we get 1 divided by x plus y, but x plus y is u, therefore which is equals to 1 divided by u. Therefore, j dash equals to 1 divided by u. Now consider j into j dash, which is equals to u into 1 divided by u, which is equals to 1. Therefore, we verified j into j dash equals to 1. Next, the fifth problem is, if u equals to x plus 3y square minus z cube, v equals to 4x square yz, and w equals to 2z square minus xy. Then evaluate del of uvw divided by del of xyz at 1 minus 1 0. Solution, we know that del of uvw divided by del of xyz equals to determinant of del u by del x, del u by del y, del u by del z, del v by del x, del v by del y, del v by del z, del w by del x, del w by del y, del w by del z, which is equals to determinant of del u by del x is 1, del u by del y is 6y, del u by del z is minus 3z square, del v by del x is 8xyz, del v by del y is 4x square z, del v by del z is 4x square, del w by del x is minus y, del w by del y is minus x, del w by del z is 4z. Now at the point 1 minus 1 0, it is put x equals to 1, y equals to minus 1, z equals to 0 in del of uvw divided by del of xyz. We get del of uvw divided by del of xyz at the point 1 minus 1 0 equals to determinant of 1 minus 6 0 0 0 minus 4 1 minus 1 0. Expand this determinant, we get del of uvw divided by del of xyz equals to 1 into 0 minus 4 plus 6 into 0 plus 4 minus 0 into something is 0, which is equals to 20. Next, the sixth problem is, if u equals to x square minus y square, v equals to 2xy, and x equals to r cos theta, y equals to r sin theta. Find del of uv divided by del of r theta. Solution, directly we can't find del of uv divided by del of r theta. That's why first we have del of uv divided by del of r theta equals to del of uv divided by del of xy into del of xy divided by del of r theta, which is equals to del of uv divided by del of r theta. First we find del of uv divided by del of xy, multiply this with del of xy divided by del of r theta, then we get del of uv divided by del of r theta. Now the given u equals to x square minus y square, v equals to 2xy. Now del of uv divided by del of xy equals to determinant of del u by del x, del u by del y, del v by del x, del v by del y, which is equals to determinant of del u by del x is 2x, del u by del y is minus 2y, del v by del x is 2y, del v by del y is 4y. Expand this determinant, we get 4x square plus 4y square, which is equals to 4 into x square plus y square. And also given x equals to r cos theta, y equals to r sin theta. Therefore, del of xy divided by del of r theta equals to determinant of del x by del r, del x by del theta, del y by del r, del y by del theta, which is equals to determinant of del x by del r is cos theta, del x by del theta is minus r sin theta, del y by del r is sin theta, del y by del theta is r cos theta. Expand the determinant, r into cos square theta minus into minus plus r into sin square theta, which is equals to r into cos square theta plus sin square theta, which is equals to r into 1, which is equals to r. Therefore, del of xy divided by del of r theta equals to r. But we have del of uv divided by del of r theta equals to del of uv divided by del of xy into del of xy divided by del of r theta. Substitute using above, which is equals to 4 into x square plus y square into r, which is equals to 4 into x square plus y square is r square into r, which is equals to 4r cube. Therefore, del of uv divided by del of r theta equals to 4r cube. Next, the seventh problem is if y1 equals to x2 into x3 by x1, y2 equals to x3 into x1 by x2, and y3 equals to x1 into x2 by x3. Then show that the Jacobian of y1, y2, y3 with respect to x1, x2, x3 is 4. Solution. Now, the given y1 equals to x2 into x3 by x1, y2 equals to x3 into x1 by x2, and y3 equals to x1 into x2 by x3. Therefore, del y1 by del x1 equals to minus of x2 into x3 by x1 square. Del y1 by del x2 equals to x3 by x1. Del y1 divided by del x3 equals to x2 divided by x1. Also, del y2 by del x1 equals to x3 by x2. Del y2 by del x2 equals to minus x3 into x1 divided by x2 square. Del y2 by del x3 equals to x1 by x2. Also, del y3 by del x1 equals to x2 by x3. Del y3 by del x2 equals to x1 by x3. And del y3 by del x3 equals to minus of x1 into x2 whole divided by x3 whole square. Now, we know that del of y1, y2, y3 divided by del of x1, x2, x3 equals to determinant of del y1 by del x1, del y1 by del x2, del y1 by del x3. The second row is del y2 by del x1, del y2 by del x2, del y2 by del x3, del y2 by del x3. Also, the third row is del y3 by del x1, del y3 by del x2, del y3 by del x3, which is equals to determinant of, substitute using above. First row is minus x2 into x3 by x1 square, x3 by x1, x2 by x1. The second row is x3 by x2 minus x3 into x2 by x2 square, x1 by x2. The third row is x2 by x3, x1 divided by x3 minus x1 into x2 divided by x3 square, which is equals to, in the above determinant, in the first row, take 1 by x square as common. In second row, take 1 by x2 square as common. In third row, take 1 by x3 square as common. We get, which is equals to 1 by x1 square, x2 square into x3 square into determinant of, the first row is minus x2 x3, x3 x1, x1 x2. The second row is x2 x3 minus x3 x1, x1 x2. The third row is x2 x3, x3 x1 minus x1 x2. In first column, take x2 x3 as common. In second column, take x3 x1 as common. In third column, take x1 x2 as common. We get del of y1, y2, y3 divided by del of x1, x2, x3 equals to minus x1 square into x2 square into x3 square divided by x1 square into x2 square into x3 square into determinant of minus 1, 1, 1, 1 minus 1, 1, 1, 1 minus 1. These two gets cancelled. Expand the determinant, minus 1 into 1 minus 1 minus of 1 into minus 1 minus 1 plus of 1 into 1 plus 1, 2 plus 2, which is equals to 4. Therefore, del of y1, y2, y3 divided by del of x1, x2, x3 equals to 4. Therefore, the Jacobian of y1, y2, y3 with respect to x1, x2, x3 is 4. Here, I given some exercises. Work these problems as above to get the required answers. I referred the textbooks Differential Calculus by Shantinarayan, P.K. Mittal, textbook of BSc Mathematics by G.K. Rangnath, textbook of Mathematics by Professor G.B. Gururajachar, textbook of BSc Mathematics by B.V. Manjunath and Dr. C. Nandish Kumar. Thank you one and all.